In this video, we are complete the all formulae of physics chapter capacitor, and the second is logic gate. In the capacitor, this is denoted by this symbol, and the unit of capacitor is farad or a microfarad. Next is very important, capacitance energy. There are three types of capacitance energy, and the three formulas are: first is U is equal to half CV square. U is the energy, V is the voltage, and C is the capacitance. Second is half QV, and third is half Q square by C. And next is parallel plate capacitor. C is equal to K permittivity A by D. K is the dielectric constant, and this is permittivity. This is a constant value 8.85 into 10 raised to minus 12. Next is area. And D is the separation between plates. And nextly we study how to solve questions of capacitors and steps to solve circuits of the capacitor. First is, there are two types of capacitor: series capacitor and the parallel capacitor. In a series capacitor, two capacitors are arranged in series, and in parallel capacitor, capacitors are arranged in a parallel manner. Series capacitor, and the formula is 1 by C1 plus 1 by C2, and this is also written in the form C1 C2 by C1 plus C2. Next is parallel capacitor, and formula is C1 plus C2. Next is net charge, means also known as total charge. How to find this net charge? Net charge is Q2 minus Q1 upon 2. And these steps we are solved. Then at the end of this, use Q is equal to CV. Q is a charge, C is a capacitance, and V is a voltage. These steps to follow, you can give answer. And Q is equal to CV. Also we can written in the C is equal to Q by V for the finding the capacitance. And first formula is used for finding the charge. Q is equal to CV and C is equal to Q by V for finding the capacitance. And this is adjustable formula. And this chapter is completed, and this is very important chapter. In this chapter, 1 or 2 questions asked in JEE and in MHTCET. Next is logic gate. So we start logic gate. This is easy and interesting chapter. In this chapter, we are studying different gates and their properties. There are 5 types of gates. First is NOT gate, second is AND gate, third is OR gate, and NON gate, and last is NOR gate. Okay, so firstly we study NOT gate. But before that, for easily understanding, we can take one example. Switch for this switch is only on or off. Similarly, in logic gate, there are two conditions. First is true or false. Either it is true or false. In all gates, only this condition is used. In logic gate, first gate is NOT gate. This is denoted by this symbol, and this is used for negationing. For negation, when A is 0, when we can take negation of A, means also we can take negation of 0, then it is 1, and then negation of 1 is 0. Next gate is OR gate. This is denoted by this symbol. And in OR gate, there are two terminals, A and B, and this is used for addition, A plus B. Output gives A plus B, means addition. We can make firstly truth table, A, B, A plus B. When A is 0, B is 1, then A plus B is 1. When A is 1, B is 0, output is 1. When A is 1, B is 1, output is not 2, 1. Output is 0. Next is AND gate, and this is represented by this symbol. There are two terminals of AND gate, A, B, and output gives product of A and B. This is used for product. And truth table is truth table of AND gate, A, B, A into B. When A is 0, B is 1, output is 0. When A is 1, B is 0, output is 0. When A is 1, B is 1, output is 1. Truth table, NOT gate, truth table, this is symbol. Next is NONE gate and the NOR gate. NONE gate is denoted by this symbol. But firstly we study for easily remembering these three gates. NOT gate. NOT gate is used for negation. A is output gives A bar, and AND gate output gives product of A into B, and the OR gate is for addition of A plus B. And the symbol for NONE gate, and NONE gate is mixing of NOT gate and the AND gate. Firstly we draw AND gate and join to AND gate, NOT gate, A, B, A into B, and their negation means bar, A into B bar. When A is 1, B is 0, then product of A into B and their negation 0, and when we take negation of 0 is 1. Similarly, negation is 1. Product is 1 and negation of 1 is 0. A is 0, B is 0, product of 0, negation is 1. Next is, this is truth table and this is symbol. Next is NOR gate. This is denoted by this symbol, and this is mixing of OR gate and NOT gate. Firstly draw OR gate and join NOT gate. There are two terminals A and the B. It gives A plus B, and next is negation, A plus B bar. And A is 0, B is 1, 0 plus 1 and their negation is 0. And A is 1, B is 0, 0 plus 1, 1 and their negation is 0. Similarly, negation is 1. A is 1, B is 1, 1 plus 1 not 2, this is 1 and negation is 0. This is the output of NOR gate. So we nextly study the properties of logic gate. So our 5 types of gates are complete. Nextly we move to the properties of logic gate. We study each and every property of logic gate. First is A plus B bar equals to bar A into bar B. Next is A into B bar, and this is bar A into bar B. Next is double negation of A is A. Also we can say negation of negation is statement itself. A plus A is equal to A. A into A is always A. And A plus A bar equals to 1. A into A bar equals to 0. This is very important. Double negation of A plus B is double negation of A into double negation of B. So we say A plus B double bar equals to bar A double bar A into double bar B. And for finding the photon's energy we use E is equal to hc by lambda. E is a photon's energy, h is a Planck constant, c is the speed of light, and lambda is a wavelength. This is very important formula. H is a Planck constant. This is constant value 6. Next is very important properties. First is forward bias, and the key is high to low, and reverse bias is low to high. And we study the diodes. There are 3 types of diode. First is photodiode. Photo means light. This is denoted by this symbol. Light is falling on an LED. Next is LED, light emitting diode. Light outward from diode, that is outward. And third is Zener diode. This is 3 diodes and their symbols. Next is solids, but firstly gate are 2 values, 0 or 1. And in solids there are 3 types of solids: metals, semiconductor and insulator. And energy gap is 0 electron volt for metal, semiconductor 1 electron volt, and the insulator energy gap is greater than 5 electron volt. Next we move to the semiconductor, and this is elements of group 4, and the valence electron is 4. Intrinsic semiconductor. There are two types of semiconductor: intrinsic semiconductor and extrinsic semiconductor. Intrinsic semiconductors are pure semiconductors. This conduct electrons and the holes, and the formula is Ni equal to number of electron equal to number of holes. Extrinsic semiconductor, but we study gaps, energy gap concept. Energy gap means the gap between conduction band and the valence band. There are two types of bands. First is conduction band, next is valence band. The gap between conduction band and the valence band, this is energy gap and the energy band. And the definition of an energy band is the gap between conduction band and the valence band is called as the energy band. Next is extrinsic semiconductor. This is impure semiconductor. Extrinsic semiconductor are the two types, P types and N type. P type contain holes and N type contain electrons. And in P type contain number of holes is greater than number of electrons, and in N type number of electron is greater than number of holes. P-type dopant is acceptor, and in N-type dopant is donor. This is trivalent, this is pentavalent. An example: boron, aluminum, indium, etc. In N-type, example is antimony, phosphorus, arsenic. This is P-type is majority charge carriers of holes, and N-type is majority charge carriers of electrons. P-type and N-type is very important. Next is Ohm's law. This is very important formula. V is equals to IR. V is the voltage, and transistors are emitter, base, collector, and their current passes through emitter, base, and the collector. Alpha DC equal to alpha B DC upon 1 plus alpha DC. Beta DC equals to alpha DC upon 1 minus alpha DC. These two formulas are very important. Next we will study IV graph. Next is transistors terminals. Transistor key points of terminals we study. Emitter is heavily doped, base is lightly doped, photodiode. This is always operated in the reverse bias. Next is PN junction diode. This is mixing of P-type and the N-type and form junction and the PN junction diode. This is LED and this is forward bias.